Imagine a planet so out of place, it shatters everything we thought we knew about how worlds are born. Astronomers have just found such a world, one that simply shouldn't exist. Our models of solar system formation have worked for decades, predicting what kinds of planets form around which stars. But this discovery is a cosmic curveball, a contradiction that forces us to question the very foundations of planetary science. This isn't a minor oddity, it's a planet orbiting a star where no planet of its kind should be able to form or survive. It's like finding a penguin sunbathing in the Sahara. You know it's real, but it makes no sense. The evidence is undeniable. The data checks out. Simulations confirm it. This single impossible world is rewriting the story of creation. Science thrives on these moments, when the universe refuses to play by our rules. This planet has become a global puzzle, challenging our assumptions about how worlds are born. It's a humbling reminder, no matter how much we learn, the universe always has another surprise. So, let's journey across the light years to this enigmatic system. We'll explore why it breaks the rules, how we found it, and what wild ideas scientists are proposing to explain it. This isn't just about one weird planet. It's about the nature of discovery itself. Sometimes, a single stubborn data point can unravel decades of theory and open up thrilling new frontiers. Prepare to have your cosmic mind blown. The universe is about to show us just how creative it can be. Let's dive in. Meet Bellerophon's Folly, a planet named for a mythic hero who dared too much. What makes it so strange? It's a gas giant, bigger than Jupiter, orbiting a tiny, faint red dwarf star. Red dwarfs are the most common stars in the galaxy, but they're small, cool, and have very little material to form planets. In our solar system, Jupiter is huge, but the Sun is 1,000 times more massive. Here, the scale is all wrong. A giant planet circling a star barely bigger than a cosmic ember. Our models say a red dwarf's protoplanetary disk is too small and sparse to build a gas giant. Yet Bellerophon's Folly exists, a planet far too big for its star. It's a cosmic paradox, staring back at us through our telescopes. Where did all the material come from? How did it form? The planet's very existence tells us we're missing a huge piece of the puzzle. This is not just an oddball. It's a challenge to everything we thought we knew about planet formation, and it's forcing theorists back to the drawing board. Let's zoom in on the home of Bellerophon's Folly. The star, LHS 3154, is a red dwarf about 50 light-years away, so faint you'd never see it with the naked eye. It's only 9% the mass of our Sun. If it replaced our Sun, Earth would freeze solid. Now the planet LHS 3154b, a gas giant at least 13 times the mass of Jupiter. That's a mass ratio off the charts. In our solar system, Jupiter is a tiny fraction of the Sun's mass. Here, the planet is more than 1% of its star's mass. Unprecedented. According to the core accretion model, planets form from dust grains sticking together, building up to a solid core, then grabbing gas. But a red dwarf's disk shouldn't have enough material to build even a small rocky planet, let alone a super Jupiter. The star's winds would blow away the gas before a giant planet could form. By all logic, this system should only have small, rocky worlds. Yet, here's a gas giant, a manufacturing impossibility. It's like finding a jumbo jet built in a bicycle factory. Discovering Bellerophon's Folly took ingenuity and patience. You can't see the planet directly. It's lost in the glare of its star. Instead, astronomers used the radial velocity method, looking for the star's tiny wobble as the planet tugs on it. Think of a dancer spinning with a much smaller partner. The big dancer wobbles just a bit. As the star wobbles, its light shifts, blue as it moves toward us, red as it moves away. This Doppler effect is measured with a high-precision spectrograph. For years, astronomers watched LHS 3154, collecting data. Eventually, a clear periodic wobble emerged, far larger than expected for such a small star. The size of the wobble revealed a planet at least 13 times Jupiter's mass. The team checked and rechecked, ruling out errors. The signal was real. They'd found a planet so massive it stretched the laws of physics. Bellerophon's Folly was discovered, not by sight, but by its powerful influence on its tiny sun. It's a ghost in the machine, demanding an explanation, and it's just the beginning of the mystery. Bellerophon's Folly doesn't just bend the rules, it shatters them. The core accretion model, our leading theory, says you need lots of solid material to build a giant planet. But a red dwarf's disk has less than an Earth's mass of dust, nowhere near enough to build a super Jupiter. The math just doesn't add up. So we turn to another idea, gravitational instability. Here, a massive disk collapses directly into a giant planet. But again, a red dwarf's disk shouldn't be massive enough for this to work. Neither mainstream theory can explain Bellerophon's Folly. It's a cosmic product with no known factory. When theories fail, it's time to get creative. Maybe the planet didn't form here at all. One idea. Bellerophon's Folly was born in another system, ejected as a rogue planet, and later captured by LHS 3154. It's a long shot. Space is vast, and such captures are rare but not impossible. Another scenario. In a crowded stellar nursery, stars can pass close and steal planets from each other. Perhaps LHS 3154 snatched Bellerophon's Folly from a neighbor in a cosmic game of billiards. Both ideas are dramatic, but they sidestep the formation problem. Sometimes the universe plays by rules we haven't even imagined, and sometimes it just gets lucky. Here's a radical idea. What if Bellerophon's Folly is a second-chance planet? Maybe LHS 3154 once had a massive companion star that died, leaving behind a white dwarf. The dying star could have ejected material, forming a new enriched disk around the red dwarf. From this disk, a second generation of planets could form, including a giant like Bellerophon's Folly. If true, we might find a faint white dwarf still orbiting the system, a smoking gun for this theory. This would mean planets can be born from the ashes of dead stars. The search is on for this hidden companion. If found, it would rewrite our understanding of where and how planets can form. Why does this matter? Because it changes our search for life. Red dwarfs are the most common stars, but we thought they only hosted small, rocky planets, often in harsh, tidally locked orbits. Bellerophon's Folly proves giant planets can exist here, and giant planets can have moons. Imagine a large rocky moon orbiting a gas giant, shielded from flares with a regular day-night cycle. Suddenly, the most common star systems could host habitable exomoons. If even a fraction of red dwarfs have giant planets with moons, the number of potential cradles for life skyrockets. Bellerophon's Folly has given us a new hope, a new place to look for life. The impossible planet points us to possibilities we never considered. The search for life just got a lot more interesting. Bellerophon's Folly is a perfect example of why science is so thrilling. Every time we think we understand the universe, it throws us a new mystery. This bizarre planet shows our theories are incomplete, and that's exciting. Each anomaly broadens our sense of what's possible and where life might exist. The universe has more imagination than we do. So let's keep looking up, building better telescopes, and embracing the unknown. The anomalies are signposts, pointing us toward deeper truths. The universe isn't obligated to make sense, but it's our privilege to try to understand it. Bellerophon's Folly is a cosmic invitation to ask better questions and dream bigger dreams. The journey has just begun.